We're going to go over all these problems real quick. Okay, first of all, let's make sure we got the right data set. Week 3 in data class. So to get there, we go here. And here's our canvas. And then on the side over here that you can't see, I'm going to modules. And we're going down to week 3. That's the one where we're not meeting officially. So that's here. And you're going to go down here. And this is what this video will be about. It'll be about this one right here. So normally we would do it in class, but I'm just going to make a video on how it's done. Not to be confused with the guided homeworks, okay? These are for your edification only, but I strongly suggest you look at the PDF, and if you can't figure out how to answer the questions, watch the answer videos. They're all pretty basic there, but this one is got a little bit more. I think we're going to do a split file in select cases, but let's get on it. So click on this one first, boom, and that takes you to the worksheet. And then click on this one second, boom. And this should open up the SPSS sheet. There it is. Okay, so we're ready to go. First question, let's find out what the first question is. Pie chart name gender. Are there more females than males? Pie chart name gender. So there's a lot of way to make pie charts. So we could go to the chart builder. And for the chart builder, you want to, let me get this up on the screen for you here, boom. If we're going to do a pie chart, we want to scroll down to pie. Oops, can you see that? Pie. Pie. And then you drag it up there. And then you want the slices by gender. And you're basically done. You can change the colors if you want. And we're going to get an output. Dun, 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 there it is. So there's a lot more blue. And blue is females. So yes, there's more females than there is males. So there's another way to do that real quick. We can go to graphs. We can go to legacy. I normally go to legacy. It's just faster. Pie, same thing. Define. What do you want the slices to be? We want the slices to be gender, right? Just define slices by. Boom. You can name it anything you want, right? Gender. And click. We should get the same thing. Look at that. 2 genders. Wow. Okay, so again, it's females. That was pretty basic. Next problem. Bar graph therapy type. Which one was the most popular? Bar graph therapy type. Same thing. I'm just going to go to graphs legacy this time. Going to go to, where's my bar? I know I'm looking right there. Bar. Boom. Simple. Stay away from the clustered, you guys. We're just doing simple stuff, easy to read. And what was it? Therapy types. That's going to be my categorical axes. And remember, this is a bar graph. So bar graphs deal with categorical variables, as do pie charts. How many are in each category? So this tells me that CBT by far is the most popular of the therapy types. And that was pretty easy. And again, I guess I should show you how to do that in the... We're going to go to chart builder, which you can't see up here. Right? Let's get that up there. Chart builder. So this time I want a bar graph. Bam. And you can get as fancy as you want. But again, I recommend simple, because simple is better. And we want therapy types. Therapy types. And we click OK. And it should look just like the other one, and it does. So, all right, moving on. A histogram of everybody's favorite subject, student loan debt. Oh boy, is it normal? Okay, here we go. Again, there's several different ways to make a histogram. Let's just go the legacy histogram. And then we want student loan debt. That should sober you up there. Right there. Boom. Boom, 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 boom. Again, you could title it if you want. I don't want to. And we're just going to put that in there. There's histogram. Does that look normal to you? No. So remember, the normal curve will follow like the hump. We call it the hump. It's called the bell curve. And this thing is kurtotic all over the place. That means it's too high in the tails. It's got too many spikes. But it is not normal. And again, I'm sorry, let me get this all the way on the screen for you here. Boom. But let's try some other ways. Here's a common one. Analyze, descriptives, explore. We're going to start checking things for normality. And this explore function is your best friend. So we would stick in, what was it, student loan debt. And we're going to go to plots. You can do the histogram here. And, very important, this normality plots with tests, that's the main one. We're going to go by these tests to tell you if it's significantly violating the assumption of normality first. But with this function, with the explore function and descriptives, you get all the descriptives there are, right? You get all the mean, the standard deviation, the min, the max, etc., etc. But this is your money box right here at normality. Now, this is kind of awkward because with the main test that we use here, the Kolmogorov-Smirnov test, it says that it did not violate the assumption. So when we're checking assumptions, if the sig value, also known as the p-value, if that sig value is greater than 0.05, that means it did not violate. So this is saying it did not violate. But the second test, the Shapiro-Wilk, says it did violate because it's less than 0.05. And I would look at this thing and say, no, there's no way that thing is normal. But SPSS, what that little 0.200 with the asterisk means is if the sample size were to increase, more than likely this would become a normal data set. Let me say that again. When we get a Kolmogorov-Smirnov test with the asterisk, it's always the same number, 0.200. That is the software saying increase your sample size, you'll get a normal sample size. That's what that's saying. So, but it's not normal. All right, I think we got another one here. Histogram of rent. Same thing. Is it normal? Histogram of rent. So let's just go to legacy histogram. And out with the student loans, in with the rent. And boom. Again, here's the histogram. And that is not normal either, right? It's got too many highs and lows. It does not fit the hump. So I would say it's not normal, but we're going to run those tests again. We're going to go to descriptives, explore. Remember Dora the Explorer. She will tell you if these things are normal or not. Thank you, Dora. So rent. And we go to plots. And everything should be checked, right? Click the stem and leaf. Nobody uses a stem and leaf plot anymore. But you can get your histogram. Same histogram. But with this one, you'll get the Kolmogorov-Smirnov test and the Shapiro-Wilk test. Those are your tests for normality. Mathematically done. And so we're getting the same thing here. Okay. When one test says, if it's less than 0.05, that means it's violating the assumption. So the Shapiro-Wilk test says this data is not normal. The Kolmogorov-Smirnov test, because it's got that little star, that asterisk, that means if you increase your sample size, it would become normal. But it's not normal. Okay, so that's the end of that question. All right, number 5. What's the average annual income for males and females? There's more than one way to do everything in SPSS, but the fastest and easiest way would be to do this. We'd go to Analyze, Descriptive Statistics. I would probably just go to Explore again. And what was it? Annual salaries, annual income, bam. Now, this factor means categorical variable. So between the genders, I simply stick that in there. So I'm going to get a list of statistics for males and a list of statistics for females. And it looks like this. So the female mean income was $50,730. For male, it was $56,571. So it looks like males are significantly higher. What was the question? Maybe not significantly. That might have been a bad word to use at this point in time. But what was the question? Oh, what was it meant for males and females? Okay, we did that. Done. Number 6, what is the average relationship satisfaction scores for people in each of the marital status levels? Single, people, etc., etc. All right. So this is getting a little bit harder. We want to look at relationships satisfaction for each of the marital status levels. Let's find out how many there are. First of all, there's 5. 1, 2, 3, 4, 5. Okay. So we got different ways of doing that. Let's do it the way I did it before. We simply go to Analyze, Descriptives, Dora the Explorer, and we put in relationship satisfaction, and we put in marital status, kick out gender, boom. And it's going to give us that giant printout of each group. So here's all the relationship satisfaction groups, right? The different levels of that categorical variable. How many are missing? How many are in each group? And so there's the mean relationship for single is 22. For married, it's 25. Separated, it's 19. Divorced is 10. Widowed is 22. And that's it. So it's obvious, according to this, that the highest is being married. Married is bliss, is all we married people know that. But okay, so I'm going to show you a different way. We're going to split the file. What that means is this. We go to data. We go all the way down here to the bottom. It says split file. Split file. We click compare groups. On condition that we're going to put whatever we do from now on after we split groups, we're going to get a separate output for each of the levels of marital status. So let me just show you that real quick. So we go to Analyze, Descriptives. This one I'm going to make a quickie. We're just going to do frequencies. And I want relationship satisfaction. And I've got to put this all the way over here so you can see it. Boom. And what am I looking for? I am looking for the means, right? What the heck? I'll do the means and standard deviations because they're, married. The mean is the king and the standard deviation is the queen of statistics. And we click OK. So this is a split file. So here's the single results, right? The mean is 22. The married is 25. Separated, and I misspelled separated. Don't beat me to death there, but that's 19, divorce, right? So that's one way to do it, is the split files, besides the way we did it before, okay? So split file is very, very handy. And so that's that. All right, next up, box plots for student loan debt, rent, and relationship satisfaction. We could probably do these all at the same time, but I like to do things one at a time here. So I'm going to go to, what am I going to go? I'll go to graphs. We'll use the chart builder. I haven't used that for a while. And let me reset. Don't want to give it away. But we want to, from the gallery, we want to go to box plots. This does multiple box plots. Again, I'm not going to do the fancy ones. This is a single box plot. We can grab it up, put it up there. And so we're going to do student loan first. Boom. And then let's put that in there. And there's your student loan box right there, right? So the maximum is 120,000. The minimum is a little under 20,000. So remember, each horizontal line splits the data into fourths. Those are the quartiles. So a fourth of the people have student loans from roughly 20,000 up to 40,000. And then another fourth is roughly 40,000 up to 60,000. And that line in the middle, that's the median. So half the people have above 60,000 and half the people have below 60,000. And then again, these are split into fourths. So here's the third fourth right here. And this last fourth is between about 100,000 and 120,000. So again, the horizontal lines break the data up into fourths. That's what we call quartiles. So there's student loan. Let's go to graphs again. Let's chart builder. And then out with student loans. And let's do rent. Boom. And there's rent. Okay, hold on a second. Which is ridiculous here in San Diego. And again, that looks pretty normal. I didn't tell you, this looks relatively normal. It's not perfect, right? The median is not directly in the center, but it looks relatively normal, right? The stretches of the top and the bottom are relatively close. They're not exactly the same. So, and this one looks pretty normal to me too. And again, remember, these horizontal lines represent the quartiles. That piece of data that splits the data into fours. It's like the median, right? The median splits the data in half. A quartile splits them into fours. So there's the minimum. This is quartile 1 is 1,200. The median is around 1,400. Quartile 3 is around 1,700. And the maximum is around 2,000. So that's that. Now let's do the last one. And out with the rent and in with the relationship status. Boom. And this one is not so normal. You'll notice that the bottom leg is a lot shorter than the top leg, which kind of means it's skewed. So, but there's relationship status, and it looks skewed to me. So that's about it for that one. All right, last one. What was the overall average annual income for the people that have BA degree or higher? So they want us to use select cases. So in other words, people with a BA, MA, and PhD, they're going to be in just one big group. All right, we could do that. So BA and above, let's go here. So with this, we're going to go to data. And then select cases, which is way at the bottom. Let me see if I can get that down there for you. Select cases. If condition that, then we're going to stick in level of education. Now, I kind of forget what the levels were represented by, the numbers wise. So I got to go back here, and I'm going to look at the levels of education. So we want 4, 5, and 6. We don't want some high school. We don't want high school. We don't want some college. We want 4, 5, and 6. Let's click OK. Now I know what to do. We're going to go to, again, we're going to go to data. And all the way down to the bottom is select cases. If condition is satisfied, click on that. So level of education, we're only going to use those values that are greater than 3, right? 1 was some high school, 2 was high school diploma, 3 was some college. So that means we don't want to use those. We want to use any level that's greater than the number 3. So that's 4, 5, and 6. Okay. So that's what we're going to do. So now if we, having set those parameters, we can simply go to analyze any one of these, right? Frequencies, descriptives, explore, they all give you the same information. But I'm going to just go to frequencies, and I'm going to look at, and I already forgot what the question was. Income, annual income. And I just want the average there, the mean and standard deviation. Sure, why not? And this is our one big group here, right? So the mean of just those 3 groups is $51,437. Period. So that's how that works. You could have done it individually. You could have broken them down by split file and then added up the bachelor's, master's, and PhD and divided that by 3. But that's too hard. But that's how you use select cases. And the same little warning here: whenever you select cases, please, oh please, oh please, go back and unsplit the cases. Hold on a second. Come here, you stupid computer. Boom. Right, we're going to go back to reset the select cases. So next time we do it, we do all the way Jose. So I almost forgot to show you something kind of important. When you select cases and you have people that you're not using, it'll show up in the output sheet, right? So you go to the, it shows up in the data sheet. You click data, and you see the ones with the lines through them. That means they will not be used. That's what that line means through the gray number. That these people did not fit the criteria, so they will not be used in the calculations. So that's it. MGZ out.